This is the third lesson in the angles unit. We're talking about parallel lines and their transversal. The homework that goes along with the first day of this is page 7 to 9. All right, I want you to do these problems for a warm-up. Go ahead and pause the video at this point so you can do them. All right, after you've done them, you should have gotten these answers. X is 95 and Y is 23. How would you go about solving? Well, if I'm this is a quadrilateral. It's got 4 sides and 4 angles. Every quadrilateral in the world, the angles, the interior angles right here, add up to 180 degrees. If you cannot remember that, think about a square. No, I said 180, it's 360. Think about a square. Doesn't a square have 4 right angles? A rectangle also has 4 right angles. Well, 4 times 90 is 360. Every quadrilateral in the world has 360 degrees. So, I can write an equation. X plus 68 plus 95 plus 102 equals 360. So, if you are going to solve this, you're going to add 68 plus 95 plus 102, and you get x plus 265 is 360. Subtract 265 from both sides, and you end up with x is 95. Now, same thing over here with the triangle. What are the 3 angles in every triangle in the world add up to? 180. So your equation, y plus 85 plus 72 has to equal 180. Solve this. Y plus 157 equals 180. Subtract 157, and you end up with y is 23. Now, you do not necessarily need to write an equation for those, but you could. All right, I want you to pause and do this problem. All right, let me move this so you can see what you should have gotten. You should have gotten 32. All right, these are like puzzle type problems. Let's read what it says. 3 lines, AD, BE, and CF intersect at point O as shown in the diagram. AD is perpendicular to FC. So right here, it's perpendicular, they intersect at the right angle. Angle EOD measures 32 degrees. What is the measure of angle AOB? Well, this is a relatively easy problem. Take a look at these 2 angles. Aren't they vertical angles? So if this is 32, this is also 32. Vertical angles are congruent. All right, again, pause this and work it out. All right, you should have ended up with the measure of angle ABC is 55 degrees. 55. I know you can't see that because it's outside of my, it's 55 degrees. So, it says sides AD and CD of trapezoid ABC are extended as shown. The measures of angles CDE, and EDF are 2x plus 1 and x minus 7. Find the measure of angle ABC. So, they want us to find angle ADC right here. Well, first thing I need to do is find x. Take a look at these 2 angles. Aren't they a linear pair or supplementary? So our angle relationship would be that they add up to 180. So 2x plus 1 plus x minus 7 equals 180. So when I solve this, I'm going to have 3x minus 6 when I combine my terms over here equals 180. Add 6 to both sides. 3x is 186. Divide both sides by 3. X is 62. Now, we need to find this angle. Well, can I find this angle right here? 62 minus 7 is 55. These 2 are vertical, so this one's 55 degrees. If I want to find this angle, I can do 2 times 62 plus 1 is 122 and 123. 60 125, so is this. I could also just done 180 minus 55 to give me 125. Okay, again, pause this to do this problem. All right, you should have ended up with these answers. Let's work it out. We need to find this angle right down here. So, let's look at the angle relationship. These two angles are a linear pair or supplementary. So again, 3x plus 5 plus x plus 11 has to equal 180 because they form a linear pair. So combine my terms, 4x plus 16 equals 180. Subtract 16 from both sides. 4x is 164. Divide both sides by 4. And x is 41. So once you know x is 41, I'm looking for this angle. So I would substitute 41 into the one that is a vertical angle with it. So 3 times 41 plus 5 is 128. So this angle is 128. That means this angle is 128. And I can either, what other angle are we looking for? Angle ECD, angle ECD right here. I can either subtract from 180 or I can substitute and use vertical. And I end up with 52. Because this is 41 plus 11 is 52. So that's 52 also. All right. Now, this is the start of our lesson. The other problems were warm-up practice type problem. We are on page number 10 in your notes. Okay, we are talking about perpendicular and parallel lines. The symbols. Parallel lines looks like two railroad tracks. This is perpendicular. Define it in your own words. We can say train tracks. This would be an intersection. It forms a T. Draw parallel lines. Now, this is the key. I have two parallel lines. I'm going to draw two lines, and then I am going to put on them these two little arrows. That is the notation, and everybody knows that those are two parallel lines. If I draw two perpendicular lines, perpendicular lines intersect and form a right angle. So that's the definition of perpendicular lines. They intersect, but they form a right angle. So you need to draw the right angle in. All right. Now, get to this page. We're going to talk about the names of different angles in this diagram. These are two parallel lines. This line that cuts across them is called a transversal. Now, take a look at this diagram. If you look at between the two parallel lines and call that the interior, it's inside, then outside, above and below the parallel lines, that's the exterior. So, interior angles are 3, 4, 5, and 6. Exterior, 1, 2, 8, and 7. Now, all of these angles have special names. If you look at one angle called, we've already talked about this. 2 and 4 are vertical, 1 and 3 are vertical, 6 and 8 vertical, 5 and 7 vertical. Then we've got our linear pairs, 1 and 2, 4 and 3, 2 and 3, 1 and 4, same thing in the bottom column. Now, then we have special names of the other angles. Take a look at angle 4 and angle 6. These are what we call alternate interior angles. Because they're on the inside, but they're on the opposite sides of the transversal. The other pair of alternate interior are 3 and 5. So that's one type of angle, alternate interior. Then we've got alternate exterior. Look, 2 and 8. They are on opposite sides of the transversal, but on exterior. So 2 and 8 are alternate exterior, and 1 and 7. Now, there's another term that I want you to write down. Write down same side interior and same side exterior. When you name these angles, I think they're actually pretty much common sense. So, same side interior. One pair of both on the inside, interior. And the other pair would be angle 3 and angle 6. Another name that we need to know are same side exterior. So, same thing, look. 1 and 8 are on the same side of the transversal, but they are exterior. So angle 1 and angle 8. And the other pair of same side exterior are angle 2 and angle 7. Last type. This is the Terezi. Corresponding. This is the Terezi definition. Same spot, different clump. Same spot, different clump. That's corresponding angles. So, look at this top clump. Angle 1 is in the upper left of the top clump. Which one is in the upper left of the bottom clump? 5. So, 1 and 5 are corresponding. What's another pair of corresponding? 2 and 6. Upper right, upper right. Other pair of corresponding. 3 and 7, that's lower right, lower right. And angle 4 and angle 8 are also corresponding. Now, the key here is corresponding angles are equal. They are equal. Now, I'm going to draw a picture. Because if you understand this, all of these angle problems with parallel lines, look, these lines are parallel, they are cut by a transversal. I'm going to say that this angle is 50 degrees. Now, if you know that that angle is 50 degrees, you can find every other angle on this diagram. Look at this top clump. We've been doing this for a while. This is 50, so the one directly across from it, they are vertical, they are congruent. So that is 50. Now, take a look at these two angles up here. Don't they form a straight line? So this angle will be 180 minus 50 is 130. If that angle is 130, right across from it vertically is 130. So we just found that whole clump. Now, the nice thing about parallel lines that are cut by a transversal, this clump is exactly the same as the clump down here. Slide it down. So look, this angle is 50, its corresponding angle is 50. This one is 50, this one is 130, and this one is 130. So, corresponding angles are equal. Now, if I ask you a question, are alternate interior angles congruent? Take a look at this diagram. Yes, they are. Alternate interior angles are congruent. What about same side interior? Well, look at these two same side interior. They are supplementary. 130 plus 50 is 180. What about same side exterior? 50 and 130, they are supplementary. How about alternate exterior? Look at the alternate exterior. This one and this one. They are congruent. So you can take a look at a diagram like this and figure out all the angle relationships. The key is knowing how to find an angle clump. And then you can slide the clump right down to the bottom clump. This is corresponding angles are congruent. All right, let's take a look at some examples. If you want to write notation for this, this would be line M is perpendicular to line N. This would be line P is parallel to line Q. That's what the notations are. All right, classify these angles as alternate interior